you can try this one because since we have little extra time, we want to see whether we can do it. We want to practice some of these, probably all of these. So let's try this one. So write it down. We'll go back to that page where we have all the identities so that you can choose the identity from there. So let's see whether we can do it. Our left side is sin x by cosec x, sin x by cosec x plus cos x plus sec x. Let's see. So again, you might have multiple options. So the best, let's go back to that formula page. Okay, now you might have multiple options. The best option I can see at this point is this sin x over 1 over sine, because the cosec is reciprocal to sine, plus cos x 1 over cos. So the reason of doing it, because it makes it sine square, right? Do you see it? And it makes this one cos square. So once you have sine square plus cos square x, you can get 1 from there. Now, still you are not done, because you have to what was that? Sin x times cosec x on the right side. That's what you want to do? Okay. Now once you have 1, the rest is simple, because all you need to do is, because for 1 you can just write sin x times 1 over sin x, right? Can you do it just for 1? It's still 1, right? Because sine by sine, still 1. And then sin x times 1 over sine is cosec x. 1 over sine is cosec, right? There might be other ways, but that's the best I can think of right now. So I just wrote 1. I wrote 1, and then 1 equals to sine times 1 over sine, because still this is 1, right? It's something like sin x by sin x. That's 1, right? Say it again. No, I'll go all the way up to here, because you have to start from left side and you have to go to the right side. So this is your right side, right? So you first found 1, and then I wrote 1 equals to sin x times 1 over sin x. Because you can always do that, just whatever you want. I'm saying you can write 1 equals to 100 times 1 over 100. That's still 1. Let's try this one. solving this kind of identity, verifying identity, is a kind of puzzle basically, because you have all those identities and you have to see which one would suit best. So that's why we need a lot of practice, even if we have all those formulas, and see how it will. Sometimes you might have the right answer, but you'll choose a lot of different or wrong identities that will make the way complicated. Let's go back. Let me write it down for me. All right, so let's see whether we can solve it. Anyone has good news? Anyone has solved it? You solved this? Okay. Anyone else? Okay, let's see whether we can apply some identities directly at the beginning. Okay, so from here, so first we can write 1 plus tan square equals to sec square from here, Pythagorean, which is, directly applied, which can be directly applied. So we applied it here, let's say. And then now at this point I don't see any identity I can apply directly. So let's break all of this. So what do you get if you break? Maybe for cortex you might get there are multiple ways. Let me check which one is the best one. Let's see, 1 by sine. Let's do this. Cot x equals to cos x over sine. I choose it from quotient identities. Someone might have something else. So sec square is 1 over cos square x, because it's just 1 over cos because of a square. So reciprocal identity, and then tan x equals to sine over cos. Now here you can see at the numerator we can cancel probably 1 cos x, right? There are 2 cos x. So here it will be 1 over sine x times cos x. After you cancel that cos x, I'm saying the cosine x. So it will be sine times cos, right? Okay. And here it's still sine by cos. Now now we can write this, right? Because this is divided by, so we flip the denominator and numerator. And then we cancel cos x, right? And then we are left with 1 by sine square. What is the answer? That's cos square? That's probably square here. So 1 by sine square equals to cosec square, right? Because that sine and cosec, they are reciprocal to each other. So from the reciprocal identity, you can also see that. So it's cosec square x. So you have the same step or something else? Someone else has different steps? You might have, for sure, because you can do it in a different way.
So what we tried was, at the beginning we had 1 plus tan square, we just directly applied sec square, and then we broke all of the
cot, sec, and tangent,
and then we just got raw sine cos.
We do some cancellation here,
and then the rest is just algebra, and at the end we had 1 over sine square, and we ended up 1 over sine square means cosec square, which we wanted.
Any question here? so let's try the last one, and then we'll go to some generic discussion that how we can solve or verify this kind of identities, some formal steps, but as you know that the formal steps still will not tell you exact steps, but that will give you some kind of tips. Let's try this one, which is the last one. So if you see this one carefully, look at the right side. If you want to get that right side, you have to have 10x at the numerator and 1 plus 10x in the numerator. I'm sorry, in the denominator. And the numerator you need 10x. So think about that, because you always look at your destination and see where you want to go, and try to see whether you have some kind of shortest path. So first of all, this one will be quite simple if you just follow the steps to go to the destination. All right. So, anyone got the right side? You have the right side? Anyone? This was, compared to the other ones, this is really simple if you just think about the destination. For an example, I can show you the answer, but I just wanted to share that how you get the clue. For an example, you see here, there is a sin x, and here you have to go to the 10x. Without going too much, or without looking at too much, you can just always check this one. Look at this. If you have something like cosine x divided by sine, you can go to the tangent, right? And similarly, you will also need tangent at the bottom. So again, you will need something here at the bottom. So all you can do is, you can divide your numerator and denominator by cosine x. Because you can divide denominator and denominator by the same thing, right? So let's divide it by cosine. Let's divide it by cosine. Now the objective was, if you divide it by cosine, you can directly see that this becomes tangent, right? And also, if you divide this one by cosine, this also becomes tangent, because you need tangent here as well at the denominator. So after you divide, it's extremely simple, because in the top you already get tangent, and in the bottom what happens when you divide sin x by cosine x, you get tangent, and when you divide cosine x by cosine x, that's 1, and you're done. That's exactly what you need. You might have some other route, but that's the best I can think of right now. Sometimes it really helps to see where you exactly want to go and what kind of. So these are all different kind of variants, because you see that every solution is absolutely different, because so far none of the previous ones we have never divided by something, but sometimes it also happens that you have to divide by something, you might have to multiply by something if it looks quite straight, because one of the reasons that we did that, because we looked at tangent here, and sine here, sine here. So we know that if we divide sine by cosine in both denominator and numerator, we can go to the tangent right away, and then that worked well, because other one was cosine x, that became 1, and we exactly needed 1 at the bottom. Any question here? Just to make sure, I know that you already have the algebra or some kind of algebraic equation solving knowledge for sure, but you know that, right, that you can divide the numerator and denominator by the same number or same content unless that is 0. You know that, right? Unless that is 0. So we assume that we are dividing everything by cosine x, but we always assume that some of the values of cosine x are 0. So we know that that's restricted, so those values are not applied here. In general, we assume that, because you cannot divide anything by zeros. All right, so we looked at a couple of ones, and I'm sure that you will also have to go over a lot of similar ones in the homework. So these are some guidelines for verifying trigonometric identities. Remember, as I said before, it's not like these will give you the solution, because these guidelines are not like do this, do that. It's like some tips what you can do, and some of the guidelines may be applied to some, but some of the guidelines may not be applied to some cases. But check the guidelines, and sometimes it really helps. When you do the homework, you can look at it. So these are from the book, so you have all the guidelines in the book. So first of all, what sometimes people want to do that before left side and right side, they probably, let's say, multiply both sides by something, and you cannot do that. You just
start work with more complicated side and transform it in a step-by-step fashion until it looks exactly like the other side. But remember, in most of our cases, we tried from left to right, but some cases you can also choose right to left. So that's why they said that whichever side it looks complicated, start with that, because you want to make the complicated to the easy one, because sometimes, to make the easy one complicated is not easy. So that's why they said to start with the complicated one. But in our most examples, we start from the left side. That's not always true. Analyze the identity and look for opportunities to apply the fundamental identities. Remember, sometimes when we see something directly, we apply it right away. For an example, in the previous one, we had 1 plus 10 square x. We applied the sec square right away, because some of the identities you can see it and you can apply right away, and some of the identities you will not see it, you will probably have to do some tweak and twist, then probably you can apply. Okay, so whichever you can apply, just apply it. Okay, and then try using one or more of the following techniques. As I said, there is no official steps. Rewrite the more complicated side in terms of sine and cosine. This is probably one of the lessons you'll probably have seen in most of the cases. In most of the cases, we want to go by sine and cosine. Everything, if you don't understand or if you don't know exactly what to do, one of the options is, some of the cases, just convert everything back to sine cosine, because you can do that. Everything can be converted to sine and cosine. For an example, tan x can be written as sine by cos. Cot x can be written as cosine by sine. Cosec x can be written as 1 over sine. Sec x can be written as 1 over cos. So everything at the end, you can go back to sine and cosine to make it look like all sine cosine. And then factor out the greatest common factor. That sometimes works. And separate the single quotient with 2 terms. We did it here basically. We did it here because we separated. We basically divided sine x by cosine x, and then cosine x by cosine x. Sometimes that works. So instead of having like this, you can divide it like this. Then you can apply trigonometric identities here if you have any. Combine fractional expression using the least common denominator. Multiply the numerator and denominator by a binomial factor that appears both sides of that. So sometimes even you can also divide, which we did here. Or maybe, sometimes people think a different way. We divide it by cosine x, or sometimes people say we multiplied it by 1 over cosine x, which is the same thing, right? So instead of just saying that divided by cosine x, if you say we multiply it by 1 over cosine x, that's exactly the same thing. But read the last comment. That's probably the most important part. Don't be afraid to stop and start over again, because it's so trivial. Because if you are not going anywhere, still you are fine, because you can start over. Because it's something like puzzle. Creative puzzle solvers know that the strategies leading to the dead ends often provide good problem solving, because you will know from there. And practice means you will never have the right steps at the beginning. Do it, you will not be able to go to the destination. Try it again. But over those try and error phases, you will basically learn what mistake you made in different steps, why you went to the wrong direction. Okay, because you will have all those access to all the identities, but some of the identities you can apply, but that will not lead you to the destination, and you will learn over the time when you practice a lot. Okay,
make sure you do enough practice for these identities. Now let's see. So here we have some more, and we'll try some of these, not too many, but we'll try all of these. But remember, as I said before, now we have some guidelines. Remember, the guidelines are not the solution, will not lead you to the destination always, but we'll follow the guideline. For an example here, let's say if we have to simplify this one, first of all we look at whether we can apply some identity directly. I don't remember any, so I don't think any identity we have here to apply for 1 minus sec x minus 1 or sec x plus 1. Okay, so what you can do? One option is go by sine cosine. I'm saying convert everything back to sine cosine. So what option you have for that? Sec x equals to what? 1 over cosine, right? Let's try that. Try and see what you get. Just write sec x equals to 1 over cos and see what you can come up with. Any good luck? Did you find any clue? Okay, so what you had was sec x, let's see, 1 over cosine minus 1, 1 over cosine plus 1. Now let's do a little bit more. Just let's write it 1 minus cosine x over cosine here, and this is 1 over 1 plus cosine here, right? And then let's multiply both factors. Once we multiply it, the denominator will be cos square x. And the numerator, once you multiply 1 minus cosine x times 1 plus cosine x, you will get 1 minus cosine square x. If you multiply it, you know how to multiply it, right? And then I think we can see it now. 1 minus cosine square, what is that? Sine, right? Remember, the sine square plus cosine square equals to 1. From that we can write 1 minus cosine equals to sine, 1 minus sine equals to cosine. So this becomes sine right now. And sine square minus cos square x, which is? So the right answer is D here. So you can always write my steps, but try to see how we did it. That's probably more important than. Which is same, yeah. That's the same thing. I did not do that just because in that case I would have talked about the formula, because there is a formula a square minus b square, which makes it a plus b times a minus b. I did not want to go to that route because I don't want to talk about the formula. So but that's the same thing. Even you can apply the direct. You can apply another identity from there, identity there to get the answer. So let me show what another option is, what she tried and what I'm talking about. You can do this. For an example, remember there is identity there is identity like this. Remember this one? Okay, now from here, you can always adjust the identity, get another one. So from here, you can always write let me write it this way. You can always write 10 square x equals to sec square x minus 1, right? From here. Now, so already you know it. So you know it from the identity. Now here, what you can do is you can just you can multiply it right away instead of going to the sine and cosine. I was just trying to follow the guideline to make it easy for you, but you can also do this. Just multiply this, and then you will get this. Now you see the left side. You see this one here? You can directly write 10 square x. That's another option. Now it's up to you which one you like. But this one was like, I don't understand anything, let's go back to all sine, cosine. That will also work. Now it's up to you which one you like. Now let's try the next one. Alright, as I said before, if you do not think of anything, just do sine, cosine and see what you get. So this is another one. There is the easy route, sure, but if you don't go to, don't see it, just apply sine, cosine for everything. Let's try it first with sine, cosine, and then I'll show you there are several other ways as well. Let's see whether we can find any clue just using sine, cosine. Now, if you apply sine, cosine, how you start? You will just write sec square equals to 1 over cos square, because you want to find everything. So you want to define everything in terms of sine and cosine, and this is going to be 1 by sine square. Now you know that 1 minus sine square equals to cosine square, right? 1 minus sine square equals to cosine square, right? So it's just 1. So the right answer is A. There are other options too, but I think this is too easy, so what we did is we know that sine square plus cos square x equals to 1. From there, you can always write 1 minus sine square x equals to cos square x, or 1 minus cos square x equals to sine square x. That's why we just directly wrote 1 minus sine square x equals to cos square x. So the right answer is A here. Any question? Okay, so this is going to be the last one for this section. So we don't have that much theory here in this section, so all of these are like verifying the identities, so that's why I know we have some time, so we spend some time here to practice. And again, if you don't see anything, just define everything in terms of sine and cos. Make everything sine and cosine and see what you get from here. Alright, so anyone has answer? Everyone A? Everyone has A? Alright, let's see. Let's define everything in terms of sine, cosine. So I'm writing everything in terms of sine and cosine. So our sec x equals to 1 over cosine. Tangent equals to 1 over, sine over cosine. And cot x equals to cosine over sine. Now, so this is going to be 1 over cosec square x. And here we'll have sine square over cos square x. Now, what you can do next? Take the common divisor and then cos square 1 minus sine square x, which makes it cos square x over cos square x equals to 1. So the right answer is A. Again, you might have some different options, but this is what we tried, and that's the easiest path we had. Any question?